Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 5i. Myself, Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025 Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 10 presentations, and each presenter will be given 10 minutes for the presentations and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session, Professor Ronak Kumar N. Patel. Sir is an assistant professor in the Computer Engineering Department at CSPIT Gujarat, India. With over 7 years of research experience, his expertise spans machine learning, deep learning, and recommender systems. His area of interest are Python programming, parallel programming, high performance computing, and operating system. He has served as a reviewer for international conference and have numerous research papers in esteemed international journals and conferences. Welcome to the session, sir. So we'll be moving on with the presentation. The session chair will join in few minutes. First, we have Harsh Abhinandan to present his paper titled A Comprehensive Review of Advancements in Powering and Charging Systems for Unmanned Aerial Vehicles. Are you there, Harsh?
Yes, am I audible?
Yeah, you are audible. You may please begin with the presentation.
Okay, thank you.
Yeah, your screen is visible. You may start.
Good morning, everyone. My name is Harsha Binandan from the School of Electrical and Electronics Engineering at VIT Vellore. So today I'll be presenting a paper titled A Comprehensive Review of Advancement in Powering and Charging System for Unmanned Aerial Vehicle. This review addresses one of the most critical hurdles in modern aviation technology, the limitation of flight endurance in drones, and the technological stride being made to overcome it. So, here is a brief outline of what we'll cover today. I'll begin by summarizing the operational limitation we currently face. We will then examine the taxonomy of existing powering system and compare primary power sources. From there, we'll deep dive into replenishment strategy, specifically focusing on ground methods and wireless power transfer technologies. Finally, we'll discuss the critical enabling technology, current research gaps, and the future trajectory. So, UAV has evolved rapidly. We have seen them transition from specialized military assets to ubiquitous tool used in agriculture, logistics, and surveillance. However, despite their advancement, they face a significant bottleneck, which is finite endurance. Most multi-motor drones are strictly limited to flight time of 20 to 30 minutes due to energy density limitation of lithium-ion batteries. This create a problem of operational discontinuity. If a drone has to land every 30 minutes for a human to manually plug it in, we cannot achieve truly autonomous persistent missions. This gap is what our review aims to address. To analyze the solution, we have categorized the landscape into four main pillars: power source, the onboard energy storage itself, such as battery or fuel cell, on-ground replenishment, physical infrastructure like swapping station or contact pads, Wireless power transfer, which allows for contactless charging and enabling technology, the subsystems like BMS and navigation that makes charging possible. Let's look at the first power source first. So, lithium polymer batteries remain the industry standards because they are reliable and can deliver the high peak power need for takeoff. However, their energy density restrict flight time. Hydrogen fuel cell are compelling alternative. They offer superior energy density up to 150 times of that of lithium polymer, enabling flight times of 2 to 4 hours. However, they are expensive and complex to manage thermally. Combustion engine offers higher payload and endurance, but it's too noisy and polluting for many urban applications. Finally, solar PV offers theoretically indefinite flight, but only for a fixed wing aircraft. They simply cannot generate enough surface area power for a rotatory drone. When a drone must land to recharge, we currently have two primary physical strategy. First is automated battery swapping, in which a robotic arm physically replaces the dead battery. The massive advantage here is downtime. The drone is back in the air in seconds. However, the mechanical complexity and infrastructure cost makes it difficult to scale. Second is contact-based charging, where the drone lands on a conductive plate. The efficiency is almost over 90% of the energy transfer, but the exposed electrodes are vulnerable to corrosion and oxidation in outdoor environment, which leads to maintenance issue over time. This brings us to the most promising area of research, which is wireless power transfer. Inductive power transfer is the most mature technology. It uses magnetical coupling between coils. It is safe, weatherproof, and has no exposed contacts. However, its efficiency dropped drastically if the drones even lands slightly off the center. Alternative is capacitive power transfer. Uses electric field. It is lighter and produces less electromagnetic interference, but it requires the drone to land within millimeter precision to bridge the tiny air gap, which is operationally difficult in a windy condition. F- moving beyond ground station, we reviewed novel concept designed to keep drone in air indefinitely. So the two concepts we are discussing are far field WPT, includes beam energy via laser or microwave. This allow for in-flight charging while promising the end-to-end efficiency and currently very low, which is very low, less than 15%. And there are significant safety concerns regarding high energy beams. Another innovative concept is drone-to-drone charging. Imagine a supportive UAV flying to a dock with a mission with a mission UAV mid-air to transfer power. This is critical for application like electronic warfare or border surveillance where ground infrastructure is unavailable. A charging system is only as good as its supporting subsystem. In power electronics, we are seeing a shift towards wide bandgap devices like gallium nitride. These allow converters to be smaller, more efficient, reducing the dead weight penalty on the drone. We also need intelligent battery management system that allows AI to predict the battery state of health and manages the intense heat during fast charging. Finally, navigation is key. In GPS denied environment, drone must use SLAM algorithm to locate the charging pad precisely. Despite these advancements, significant gaps remains. Technically, misalignment tolerance in wireless charging is the biggest hurdle. We need better coil topology that can maintain high efficiency even if the drone lands 10 or 30 centimeter off target. We also face swap-C constraint, onboard charging hardware, which adds dead weight, reducing the payload capacity. On socio-technical side, we lack standardized regulation. There are no universal protocol for how different drones should interact with different charging networks, and public safety regarding high power transmission which remains a concern. Looking forward, we envision an integrated ecosystem. We are moving towards networked fleet where AI manages swarms of drones, routing them to the nearest available charger based on mission priority. We also see a rise in hybrid architecture, combining the crucial efficiency of solar, the endurance of hydrogen, and the peak power of battery. Finally, I structural integration in the future where the framework material itself act as a battery or a wireless receiver, effectively reducing the charger weight to zero. To conclude our review, we indicate that no single power solution fits every scenario. While conductive charging is currently the most efficient, wireless power transfer emerges as the dominant standard for rugged outdoor autonomous autonomy because of its environmental resilience. The path forward requires bridging gap between lab validated concept and the real world deployment. This will require interdisciplinary research that address both the engineering challenges of misalignment and regulatory challenges of safety. Thank you for your attention. I am now open to any questions we have.
Thank you so much for your presentation. Sir, do you have any questions?
No, but it is a nice presentation, and whatever you have done, it's a good one.
Okay, thank you so much.
Thank you
So,
so
so we'll be moving on to the next presentation now. Next, we have Dushyant to present the paper title AI-driven personalized curriculum and learning experience using AR VR. Are you there, Dushyant?
Hello, am I audible?
Yes, you are audible. You may please begin with the presentation.
Thank you. Hello, good.
Yes, yes, Dushyant, your screen is visible.
Yeah,
You may start now.
hello, good morning, good afternoon. My name is Dushyant Varun. I'm from SRM University. This is my first conference, and I'm very thankful to ICTS for it. So today I'm going to present about AI-driven personalized curriculum and learning experience using AR VR. This system is designed to overcome the limitations overcome the limit overcome the limitations traditional and purely digital platforms by delivering immersive, intelligent, and user-centric education. I will explain the intro of this using education is increasingly shifting towards digital platforms, but traditional methods and even standard mobile and web-based learning system struggle to meet the learning preferences of students and the increasingly technological world that we live in. Um, while existing, these platforms provide interaction, they lack that deep immersive experience that students want to experience in education. Uh, while they're to understand complex concepts to easily understanding adaptive intelligence sorry to address this gap, This system integrates AI for its intelligence purposes, AR for its contextual learning, and VR for its immersive simulation, creating a unified and scalable learning ecosystem. Uh, Incorporating both AR and VR for visualization practice, it helps them understand uh, the things that are not easily learned through traditional methods. In classroom, the recorded lectures can help students to improve their reinforced learning, and it will help them uh, revise the topics much easier and quicker. Next, we are going to look into that systems architecture overview, and this system follows a microservices based architecture which are coordinated through an API gateway. The API gateway acts as an entry point for the client requests, and it is responsible for the request routing, authentication, rate limiting, and the service coordinations. The core backend services of this system include user management service, content curriculum services, gamification service, and analytical service, also with authorization services. To support this performance delivery of large multimedia assets such as 3D models, content from AR and VR environments. The system uses a, CDN storage, and it helps as it provides a low latency, faster loading time, and immersive experience, which is important for AR and VR applications. Um, as for the collaborative live interaction sessions, a real-time synchronization layer ensures instant state updates across users and their devices. Next, we are going to look at the mobile AR application for the AR side of this project. It enhances the overlaying digital information onto the physical world. It supports the marker-based and markerless tracking, um, for which the marker-based tracking, which acts like the real-time example, such as like Google Lens, as it detects images or QR code, and it overlays the animation or 3D models for contextual exploration, making the content more immersive. As for the markerless tracking, the experience is launched through a mobile app or website. The link in which the content is already stored, um, it allows the learners to scan via textbooks or objects. It also gives them access to the 3D visualizations and a demonstration within their real world environment. This approach improves conceptual their understanding, and very keeps them very engaged. As for the VR side, it usually involves a headset such as Vision Pro or and etc. And it helps them conduct virtual experiments, and instead of traditional methods or accessing a lab, it might be cost might be initially it would be high, but furthermore it would leverage the institution benefits on the long run. Um, it reconstructs the products and environment, and understand its nature, analyzing the abstract concepts spatially skills through simulations. It supports both the collaborative sessions and the single learning users, where they can interact in the virtual space. A built-in dashboard will improve their performances and ensuring their outcomes are measurable. Mm. And since the both networks needs to be unified, it have to be unified using a seamlessly through a web-based dashboard, and the platforms are all communicated through cloud-based structures. Mm, cloud-based, yeah, here it is, yeah. Cloud-based structures such as Google Cloud Platform or an Azure, ensuring their consistency, scalability, and the real data synchronization across devices, ensuring that student can access the content from all using their profiles. It stores their preferences, learning style indicators, current proficiency levels of them. The framework continues track progress across platform, uses this information to adapt their content delivery. Learning completed in one environment immediately reflects the others, enabling them uninterrupted continuous process. For example, if a student were to complete a 25% in an AR-based laboratory module, the system analyzes their interaction patterns and learning style, updates their unified profile and difficulty level according to the student's profile. And for the web-based and VR simulation will also be changed accordingly. This unified approach ensures their learning path, smoother transition, and technology in an optimized learning experience tailored to each level. Next, we are going to they're synchronized through the class platform. It will help them structure in a very modular delivery according across each platforms. A dynamic scheduling and a notification, and the primary interface will help them for notification and the scheduling, and it would send reminders of which study session has been over and completed, and it would change accordingly to the each learners preferences and their changes as well, yeah, and their method of studying as well.
Sorry
And
to interrupt you,
the
but you have 1 minute to conclude your presentation.
Okay, okay. And the phase one and the unit, it's all long time. And the backend will be framework has been using the AWS Google platform and the database for current curriculum modules, PostgreSQL. API is used RESTful services, real-time WebSocket connections for synchronizations. The scheme would be in a username proficiency level, and it would all be connected. Okay, next one. The results of this project will enhance the students' knowledge retention, and it would provide a free environment and accelerate their skill development. It will adapt to learner speeds, preferences, and their learning comprehension. It will provide additional materials and learning speeds of their struggles and concept. Individualization will improve their progress of each student and cater their needs. And uh, it would analyze the patterns and personalize the learning parts of each of them with the layer provides opportunities of them with hands-on interaction, providing relevant VR scenarios, pathways for their immersive experiential learning opportunities. The system minimizes and the physical laboratories and application as discussed earlier. Nevertheless, it supports the infrastructure must be placed, content development, sense of security, and with data. Future prospects of this include such as by integrating the computer vision and the sensor-based inputs, platform can infer learner engagement, cognitive load, stress loads, and respond by adjusting the content pacing and institutional support. Advanced deep learning with temporal analysis can enable early prediction of students at academic risk, allowing proactive interventions. The system can expand into mixed reality, allowing seamless transitions between AR and VR depending on the learning construct. The immersive simulations can be extended to high precision skill domains and such as surgery, engineering, assembly, and industrial training, where it's safe and repeatable and realistic. In uh, conclusion, AI-driven AR/VR learning system combines architecture, cloud scalability, secure APIs, advanced machine learning, NLPs, and both real-time interaction and immersive technologies for a personalized, engaging, and a future-ready education. If there are any questions, please kindly ask, sir. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
No, madam, just one suggestion that you can have before presentation so that will improve your presentations. That's one suggestion.
Thank you, sir. So we'll be moving on to the next presentation now. Next, we have Rimsha to present the paper title Context Aware Video Segment Search Integrating Knowledge Graphs for Query Based Retrieval. Are you there, Rimsha?
Yes, I am.
Yeah. You may please begin with the presentation.
Yeah. Good afternoon, sir. My name is Rimsha, and I'm here to present my research. Yeah. Good afternoon, sir. My name is Rimsha, and I'm here to present my research context-aware video segment search, integrating knowledge graphs for query-based retrieval. So, yeah. So basically, the motive behind doing this research was to enable context-aware video segment search based on queries. So based on natural language queries, since there is an exponential amount of video growth in the where there's an exponential amount of videos in the internet right now. Extracting relevant and specific segments from the video has become really tough and it is computationally expensive. So for that reasons, we have decided to perform this research to propose a hybrid retrieval mechanism which focuses on long form videos and educational videos, and which is computationally inexpensive and accurate. So we have used the current systems. So basically, the current systems use only short form videos, and they focus on your textual modality of the data. Since video data has audio modality, visual modality, and textual modality, we have integrated all three modalities. We have identified this gap, and we've integrated all three modalities of the video while performing a research. And the current existing systems are computationally very expensive, and to train deep learning models for long form videos makes it difficult to perform video segment search. And the current existing systems focus on more on accuracy and not on retrieval speed, which makes retrieval very tough and irrelevant to the real time systems that we require speed today. And the current existing research is more focused on either on video segmentation or on video retrieval. There is no, as per our knowledge, when we did our research, the background research for the study, there were no specific research papers that had video segment retrieval. So we have performed we've proposed an approach for video segmentation as well as video segment retrieval in our study. And we have integrated knowledge graphs into this to improve the speed and accuracy of the retrieval, so that we have semantically aware and contextually aware video segment retrieved at the end of our study. So we've used only educational data because we focus this on educational systems where this can be employed in colleges or schools or on LMS portals where we can where the student can propose a query and video segment that is relevant to the query as being retrieved from the video corpuses that are stored. So we've used educational videos from 3 minutes to 30 minutes from websites like YouTube, CS50 and edX, because we wanted to create an application for educational purposes. And since there is no specific benchmark video data set for video segment retrieval, so we begin by extracting all the content from the video, from all the three modalities of the video. So from the visual frames, the audio, and the text in the images using OCR. So for long form videos, the challenge that we faced is because it is computationally very expensive, and interpreting all the multimodal signals, and then creating context-aware queries is difficult. So we have unified all the modalities and created a single enriched text format, which represents the video segment, and then we have used those textual transcripts to segment the video into different parts based on the semantic relevance between each segment. So we have segmented the audio clips, and then each segment stores the enriched text, its start time and its end time. We use this enriched text to create the entities and relationships, and then populate that in a knowledge graph. So for that, we create vector embeddings and then knowledge graph entities and relationships, because this is a combined hybrid approach of using both vector embeddings for semantic search and contextually aware retrieval using knowledge graphs reasoning. So for vector embeddings, we've used the BERT model to create vector embeddings using mini-NM model. Uh, uh, the mini-LM model is not an LLM model. It is a small language model, so that it can be computationally inexpensive, and we can use it on our current systems and the resources that we have. So we create the vector embeddings, and then we create entities and relationships using the knowledge graph database. So we use a enriched text, and then perform pre-processing on the text to clear any noisy data from it, and then we perform named entity recognition to get the entities and then the relationships from the model. The relationships and entity triplets are extracted from the Rebel model, which is relation extraction model for end-to-end language generation, and then those entity relationship triplets are used alongside the vector embeddings that we have created for for populating the knowledge graph. So the knowledge graph contains a video node which has the metadata of the video, and it is connected to each section from the video using the section node and using the has section relationship. So each section of the node has the start time and the end time. It has the enriched text, which is the text that we had gotten from pipeline one, and then it has the vector embeddings for it. So that section node stores the section data of the video. And then we have the entity node, which is created from the entity relationship triplets. So all these nodes are populated into the knowledge graph data model, and this knowledge graph is used to retrieve our resulting uh, video segment. So for retrieval mechanism, what we do is we take the query, and then that query is pre-processed to get the vector embeddings from it, as well as the entity and relationships from the query. So the vector embeddings and the entity relationships are then combined, and then we give a combined score for each relevant segment that we receive. And then we rank those segments using MRR. And then after ranking all the segments, we display the resulting relevant segment in our system using the start time and the end time that we had stored in the section node. So how we do this is by how we do this retrieval mechanism, and the hybrid approach that we proposed is either we do vector based search for semantic where we compare the meaning of the query and the meanings in the segments, and we have graph based search which primarily focuses only on entities and relationships. So we have combined the graph based search and the vector based search to propose a hybrid approach which combines the strength for semantic reasoning as well as knowledge graph reasoning, giving us an accurate retrieval. So for graph based retrieval, the entities and relationships from the graph from the query are used to create a cipher query, which are given in Neo4j to extract the relevant nodes from our total video corpus. And if the entity relationship match that particular video segment is complete, then we assign a graph score of 1. If it is a partial match wherein wherein we only get the entity match, then we give a value of 0.7, and this 0.7 value is given by a trial and error. And if there is no match between the entities and relationships that is from the query and in the knowledge graph video corpus that we have, then we give a graph score of 0. Similarly, we also calculate a vector score. So a vector score is calculated based on the vector embeddings that we create from the query and from the vector embeddings that we create for each section. We do a similarity search, and then that similarity is being taken, which is a value between 0 and 1. So we propose a hybrid retrieval mechanism that combines the graph score as well as the similarity score And then those segments are then ranked based on the hybrid score that we've created. So for these hybrid scores, we proposed lambda one is the graph weight, and then lambda two is the vector weight. We assign weights for graph score and vector score, and that way we can get a final ranking for each relevant video segment according to the query that is being given. So how do we evaluate whether a system is correct or not, and how it works is based on two evaluation metrics, which is similarity weighted mean reciprocal rank as well as the recall
Sorry to
based.
interrupt you, but you have 1 minute to conclude your presentation.
Okay, so we have, and then we have recall. So for similarity weighted mean reciprocal rank, we rank basically it gives us whether the ranking is correct or not according to the ground truth that we have given, and the value is between 0 and 1. And recall is basically to understand whether we have successfully retrieved the segments in the top k values. So based on similarity thresholds, so we can see from the results that when we are using knowledge graph search and semantic search, we receive a value of 0.8, which means that the accuracy is good when we are using a hybrid retrieval mechanism. And if we fix the value for graph for semantic search as 0.8 and the graph search is 0.2, then we get a similarity score for top k as 0.8. So basically, in the top five retrieved segments, we receive the exact segment that we were intending to receive. So we have used direct, according to each query, we have measured whether it is giving proper relevant segment or not. Since there are no benchmarks for this, for the data set as well as a benchmark query data set and a video data set, we have done manual testing for it. So we have developed a hybrid retrieval video segment retrieval system, and we've used techniques like audio segment retrieval and optical character recognition, and we've evaluated the system using mean reciprocal similarity weighted mean reciprocal rank and similarity weighted recall, which showcase that we can use hybrid retrieval mechanism and integrate knowledge graphs with vector search in order to retrieve accurate results. In the future, we would like to integrate vision language models for capturing the visual scenes in the data and the spatial temporal movements in the video, as well as we would like to optimize the retrieval pipeline by restructuring the vector embeddings directly into as knowledge graph nodes. And we need benchmarking and evaluation metric. We need benchmarking data sets for evaluation as well as for the system itself. And we would like to use better computational resources for longer data, for longer videos like 2 hours and 3 hours of videos, and then optimize the retrieval strategy based on trial and error, based on the benchmarking data sets, and increase the and scale and improve the scalability of the system overall. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Means the scalability in terms of how you can scale that.
Sir, can you please repeat that?
Okay, so you have mentioned the scalability of your system. So how you can scale it?
So for scalability of the system, what we can do currently is that right now we are parallelly calculating the vector search and then the knowledge graph search. But what we could do in the future is that if we have enhanced large language models, if we can imply large language models to it and use visual language models to it, we can rely totally on knowledge graph retrieval. And when we can perform vector retrieval after we get the segments from the knowledge graph retrieval search, so that way we can reduce the speed of it. So we can use this in real time data sets, or employ the system into clouds, so that we can work this on larger data sets. So that comes in the future scope of the project, sir.
Okay.
Yes.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Anushka to present the paper titled Data Driven Student Performance Tracker and Career Path Recommendation. Are you there? Are you there, Anushka?
Yes, I'm present.
Yeah, you may please begin with the presentation.
Yes. Just a second.
Are you sharing the screen?
Oh, I just need a second. I'm trying to share, but it's not happening.
It's okay.
Is my screen visible?
Yeah, your screen is visible now. You may please start.
Am I audible?
Yeah, you're audible.
Okay. Good afternoon to my respected panel members and my co-presenters. My name is Anushka Soneja, and I'm going to be presenting my paper on the data-driven student performance tracker and a career path recommendation system. So the project focuses on using data analytics, machine learning, and natural language processing to help students understand not just how they're performing academically, but where they stand in terms of career readiness and employability. So I will be looking over the roadmap of our presentation first. First, we'll go over the introduction of the project, then the problem definition, then the literature review and the skill gaps identified, um, the proposed system that we're using along with its architecture, the design diagrams, implementation, and the references. So, to introduce our topic, in most academic institutions today, students receive grades, attendance percentages, and other data, but what they rarely receive is personalized guidance on what those numbers actually mean for their careers. At the same time, faculty members are often overloaded and cannot provide deep data driven advice to ensure every student is employable and performing at their best level. Our solution addresses this gap as we propose an intelligent system that synthesizes academic data and behavioral data to evaluate a student's job readiness, their specific skill gaps, and recommend targeted upskilling resources, for example, online courses, to help bridge their skill gaps. The core goal of this is to bridge the gap between academic performance and industry expectations in a scalable and automated manner. Problem definition. Firstly, data underutilization. Vast amounts of student data remains isolated and unused for career strategy. Secondly, there's a lack of visibility into skill gaps. So students and advisors do not have a quantifiable method to understand which exact skills are missing for which target job role. Thirdly, most institutions provide generic recommendations, and there's no specific actionable insights provided to students. And lastly, the complexity of analytics. Raw analytics outputs, such as ML outputs, are extremely difficult for non technical users to interpret and further act upon. So the gap we identified while we were performing our research was that most systems either give outputs to identify skill gaps or they just recommend career solutions to students. But there was no one point solution which performed all of this as well as provided course recommendations to bridge those gaps. So our proposed system, how it works is we have 4 modules. The first module performs a skill gap analysis on the student. It builds profiles per student by identifying their soft skills as well as hard skills, and then performs a gap analysis in accordance with the top 3 jobs which are suitable for that student. Then the third module will perform a course recommendation where a course is recommended in order to fulfill those missing skills to make them most ready to apply for the particular job that is most suited for the student. And we use 3 data sets. The first is the college student management data set, which contains all information regarding the student's academic performance. The second is a course recommendation data set, which performs online courses such as Udemy and Coursera courses, along with their descriptors, their tags, and what category they belong in. And lastly, we use a synthetic data set of the top 50 jobs as of 2025 and the hard skills and soft skills required for each of these. Another unique factor about our project is that we also utilize soft skills, which are extremely important in today's day and age for any job. So, using these data sets, we first compute a soft skill and hard skill match ratio. The soft skills are synthetically generated on the basis of the data gathered from the student, which we will look into later. So, a fit score awards a boost to hard skills since those are ultimately more important, and a slightly smaller boost to soft skills, and considers the GPA, attendance rate, and the score of the student. After which the skill gap analysis is done. So the missing skills are identified per student portfolio, and we develop a list of those missing skills, following which a course is recommended to complete that skill in order to be more employable. Lastly, we have an NLP module where we use the BART model to summarize all the technical findings into a downloadable PDF report card for the students so that they can refer to this in the future. So this is the system architecture. First, we have the data collection and integration. Here, all the different data sets are collected, and we develop student profiles on the basis of different hard and soft skills. Then we track the student performance, following which the skill gaps are identified. After which, our recommendation engine recommends different courses to the student. And lastly, an NLP report is developed. So the implementation, we've used Python, Pandas, and the BART model with a Hugging Face to fine tune the BART model. Our goal was to use the simplest possible technology to develop a comprehensive system which performs well with real student data. An example of developing soft skills for our system is if a student has high GPA, we infer the skill of critical thinking. And if a student performs in a lot of forum um, participation, for example, a lot of group projects or debates and such, then the skill teamwork can be inferred. Lastly, the BART summarization transforms the structured analysis into a narrative summary. An example is student S119 had an excellent academic profile. The top career fit is a technical writer, and as we can see, a report card is generated for the student, which will be downloadable and in a PDF format. So here we can see the top 3 jobs are recommended to a student along with a fit score, a hard match, missing hard skills, match soft skills, and missing soft skills. Following which, courses are recommended to the student in order to bridge those missing skills so as to be best suited for the job that they are applying for. Lastly, this is an example of the report card that is downloaded for the student. As we can see, there's an executive summary which just merges all the data that we've gathered from the top 3 modules. And then we have a full report which includes a performance summary, then feedbacks and recommendations, and then the report card is saved as a PDF. To conclude, our system works extremely well because it's a one-point solution for students. And where we look into expanding our system is by integrating it with actual college data, where we can use APIs to process real-time data for students to constantly track their performance. And another domain where we look to scale is making domain specific systems. For example, for an MBA college, the skills and areas of focus would be extremely different from that in a engineering college. So that is one other area where we look into expanding. And lastly, we want to integrate a real-time dashboard. And yeah, that's all. Anyone has any questions?
Thank you so much for your presentation. So, do you have any questions?
You have incorporated BART model. So BART model you have used for extracting the feature or directly as a recommendation.
Sorry, can you please repeat, sir? I couldn't exactly hear you.
So you have used BART model, right? So have you
Yes.
fine-tuned that BART model or you are directly using that BART model?
We fine-tuned it using the Hugging Face module so that we have better structured outputs.
From Hugging, you will directly get the model. And after that, you might need to fine-tune with some other data. That may be possible.
No, there's no further fine-tuning that has been done apart from importing the module and training it with the data that
Okay, so
we've
you
used
have
for the
directly
previous.
incorporated that Hugging Face
Yes,
BART
yes,
model.
yes.
Okay.
Thank you so
Thank
much.
you.
So we'll be moving on to the next presentation now. Next, we have Samia Khan to present the paper title Designing a Layered Cybersecurity Framework. Are you there, Samia?
Hello, yes, I'm here.
Yeah, you may please begin with your presentation.
My screen is visible.
Yeah, your screen is visible. You may please start.
Good afternoon, everyone. My name is Samia Khan, and I am from Nagpur. My paper I'm presenting a research title Designing Layered Cyber Security Framework, which integrates firewall, IDS, and honeypots. So these are the presentation outline: introduction, comparative literature survey, layered defense architecture, experimental simulation, result, survey, and conclusion, future scope. So we are living in a time when cyber attacks are not only increasing but also becoming more sophisticated. Attackers employ advanced methods like ransomware, zero-day exploit, and multi-stage attacks. In such environment, relying on only one security tool is like locking your front door while leaving your windows open. We often protect our network with a single security tool, such as firewall. We all use firewall in our day-to-day life. But just like a building cannot rely on one security gate, modern networks cannot rely on single defense mechanism. Cybersecurity today are multi-stage and intelligent, which is why security also need to be layered. So, our research focused on a simple idea. What if we combine multiple security tools into a layer so that if one fails, the next layer protects the system? This is the concept of defense in depth. Our research shows how layered model performs much better than using firewall, IDS, or honeypot alone. As the use of cloud services, IoT devices, and remote work increases, systems are exposed to more security risks. A layered security model provides protection at every level. It improves visibility of network activities and helps organization respond more effectively to modern cyber threat. So this is my comparison table, literature survey. This table compares our work with existing research. Most previous studies focus on only one or two security components. For example, some work study honeypots alone, while other integrates IDS or with firewall. However, none of these approach combining firewall, honeypot, IDS together in a single framework. A proposed work addressed in this gap by integrating all three layers, creating a fully layered defense model that provides better detection, visibility, and resilience against cyber attacks. This comparison clearly highlights the research gap and shows how your work provides a more complete and effective security solution. So, firstly, layered defense architecture. The layered defense architecture combines three tools: firewall, IDS, and honeypots. We will see one by one what is this. First layer is the firewall. It blocks unwanted or malicious traffic before it enters the network. Then IDS, it is the second layer. It continuously monitors the traffic that passes the firewall and detects suspicious or abnormal behavior in the real time. Third layer will be honeypot. It acts as a trap to attract the attackers and record their actions, giving us valuable intelligence. So this is the figure of layered defense architecture proposed in our work. Incoming traffic from the internet first passes through the firewall, which filters and blocks the malicious traffic. The allowed traffic is then monitored by IDS, which detects suspicious or abnormal activities. If an intrusion is detected, the traffic is redirected to a honeypot, which act as a dispersion layer or to trap the attackers and record their behavior. Finally, only verified and safe traffic is allowed to reach the internal network, which is shown. This layered flow ensures prevention, detection, and intelligence gathering, providing stronger protection than single security mechanism. So, technical analysis and implementation. In our study, we evaluated the layered defense architecture inside a controlled experimental simulation environment. This environment allowed us to individually deploy and test each security components, the firewall, the IDS, and the honeypot, and also observe how they perform when integrated. We use visualized platforms such as VMware, VirtualBox, and cloud-based test beds to recreate realistic attack scenario. This helps us to show how the defense layer react to different types of threats without risking any real-time infrastructure. The system also includes automated response mechanism. For example, the IDS detects a malicious IP address, the firewall can automatically block it. It significantly reduces response time and improve system resilience. To analyze the collected data, we used AI-based correlation engine that combines logs from all three layers to identify hidden attack patterns. Visual dashboards, it is easier for administrator to see ongoing threats and respond quickly. Overall, the simulation setup allows us to test accuracy, scalability, and cost efficient, ensuring that the layered model is practical and can be scaled into a larger network. This diagram shows a defense in depth network security model. Traffic from the internet first passes through the firewall, which filters unwanted or malicious traffic. If an attacker tries to enter, the IDS monitors the network and detects suspicious activity. Some suspicious activity traffic is redirected to the honeypot, which act as a decoy to trap attackers and study their behavior. Meanwhile, the internal network and users remain protected. By placing this security layer at a different points in the network, the system ensures that even if one layer bypass the network layer continues to protect the network. So firewall configuration and traffic filtering. In first layer, we use firewall. A firewall acts as a security gate. It allows safe traffic and block unsafe traffic. We tested this tools like IP tables and Windows firewall. The firewall checks IP address, ports, and protocol, and it keeps logs of all activities. These logs helps understand if anything suspicious is happening. Second one is IDS. The second layer is IDS. IDS watches the network in real time, just like a CCTV or network traffic. We use NOT and Sureka for this. They detect both known traffic and new strange behavior. When they find something suspicious, they send an alert saying what happened, and where. Third one is honeypot. The honeypot is fake system created to attract the attackers. We use Crowley and Honeypot to create these fake system. When attackers try to break into it, honeypot records everything. This helps us to learn how attackers behave and what technique they use. When they we then use this information to improve our firewall and settings. So this is the result of graph. First, firewall detection accuracy. Before the attack, the firewall performs well. In this green, we can see without attack with accuracy around 70 to 75%. However, once the attack starts, its accuracy sharply drops to 20 to 30%. Second is IDS. IDS also shows a good response before the attack, around 65 to 70%, but after the attack, it begins its accuracy reduced significantly. This means IDS can detect known threats well, but effectiveness decreases for complex or new attacks without additional support. Third one is honeypot. It moderates before the attack. After the attack starts, the accuracy drops further. This indicates that honeypots are excellent for collecting attackers' behavior and intelligence, but they cannot provide strong detection alone. Last one, we have combined all these three, firewall, IDS, and honeypot are combined. The detection accuracy remains stable around 60 to 65% even after the attack begins. Unlike individual tools, the combined model does not show a major performance drop, while the individual security tools lose losses its accuracy during the attack. The layered defense model remain resilience. This proves that the integrating multiple security layers provides stronger, more reliable protection against cyber threats. So using all three layers together is far stronger. Survey Insight, recent cybersecurity survey shows that 600 plus IT professional
Sorry to
prefer layered.
interrupt you, but you have 1 minute to conclude your presentation.
Okay. Layered security. Public sectors struggle with single tools. Zero trust architecture fully supports multiple layer defense. So to conclude, our research clearly proves that layered cybersecurity model integrates firewall, IDS, and honeypot is far more effective than using them individually. The integrated model improves detection rates, reduce false positives, and provides better real-time protection. It also produces threat intelligence that helps the system continuously improves. The future scope, this model can be enhanced with AI-driven automation, predictive analysis, and blockchain-based security logging. This approach can be used in enterprises' network, critical infrastructure, and cloud security systems, and IoT environments. So, to conclude, as the saying goes, security is not a product but a process. Layered defense turns cybersecurity into a continuous learning process rather than a single tool solution. Thank you for your attention. Any questions?
Thank you so much for your presentation. Sir, do you have any questions?
No, madam. That was nice presentation.
So we'll
Thank
be
you so
moving
much.
on. Yeah, so we'll be moving on to the next presentation now. Next, we have Shivani Sharma to present the paper titled Diacomor, a culturally tailored psychometric tool for diabetes and a comorbidity assessment in rural Himachal Pradesh. Are you there, ma'am?
Yes, ma'am.
Yeah, you may please begin with the presentation.
Is my screen is visible?
Yes, your screen is visible.
Okay. Good afternoon, everyone. I am Shivani from Indian Institute of Technology, Mandi, and today I will be presenting our work title as the Diacomor, a culturally trailed psychometric tool for diabetes and comorbidities assessment in Himachal Pradesh. Now, firstly, we start with the introduction. Diabetes is rising fast in rural India, but the awareness and early detections are still very low. Most existing study focused on the urban areas and do not even consider the rural culture, lifestyle, and traditional practices. There is also no tool that captures how rural communities in Himachal understand and manage their diabetes problem. So, to fill this gap, we create a Diacomor, a 36 item survey design specifically for the rural Himachal, and it measures the symptoms, lifestyle, traditional practices, and management behavior in rural areas. We also validate it to ensure its reliability. This is basically the first study to develop and validate a tool that captures how rural communities in Himachal understand and manage their diabetes. Now, next is the background. Diabetes is increasing worldwide and it is expected to affect nearly 800 million people by 2045. Because of this, Global Health Organization emphasizes the need for community based and culturally appropriate management for the diabetes. In India, diabetes cases also rising sharply. However, most of the research and healthcare solution focused on the cities, while ignore the rural communities. In rural areas, people face limited healthcare access, low awareness, and depend upon both traditional practices and modern medicine. But these factors are not well studied together. So, also there is no validating tool that captures the diabetes behavior, awareness, and related health conditions in rural Himachal. To fill this gap, we develop a diacom or questionnaire. So these are the objective. The primary objective of the study was to develop and validate a diacomor, a culturally relevant questionnaire for rural communities in Himachal Pradesh. This tool captures the diabetes symptoms, lifestyle, and diet habits, awareness level, and traditional health practices and management behavior. And in this study, we use a statistical analysis to identify the key component of the questionnaire and examine how factors like age, gender, education, occupation, BGL, and diabetic status influence these components. Now, next is the Diacomor questionnaire. Diacomor is a 36-item survey we developed to understand the diabetes in rural Himachal. It looks at people's health, lifestyle, awareness, and use of traditional practices like Ayurveda and yoga. It also assesses the participants' awareness of diabetes, access to healthcare, and the challenges they face in getting timely treatment. Overall, Diacomor gives a clear picture of community needs and behaviors, helping design culturally appropriate health interventions. Now, the next one is the dataset description and procedure. We approached 136 peoples from rural areas, in which 101 participants complete the study. We here used random sampling to ensure a diverse representation and included people who had lived in the villages for at least 5 years. Excluded anyone with the major cognitive and medical condition. We administered a 36-item Diacomor questionnaire through Google Form with built-in informed consent. The survey captures the demographics such as age, gender, education, occupation, BGL, and diabetic status. Data were collected from April 1 to July 1, 2024. For the analysis, we use SPSS to perform the descriptive statistic, EFA, Cronbell alpha, and apply ANOVA to see how demographics influence these factors. Now, the factor analysis and reliability. We conducted factor analysis to validate our Diacomor tool. The KMO value was 0.57 and Bartley test was significant, which means our sample was adequate for the analysis. The results revealed clear three factor named as dia health, tread health, and dia management. With the dia health with the Cronbell alpha value of 0.71, tread health with the Cronbell alpha value of 0.76, and dia management with the Cronbell alpha of 0.80. Dia health covers general health related aspects of diabetes. Tread health represents the traditional health practices, and dia management focused on how individual manage their diabetes problem. Together, these factors explain 53.56% of total variance. The mean score indicates that the participants were more aware for the general health issues with the dia health value of 2.68 and somewhat engaged with the traditional practices with the tread health value of 2.02 and less confident in managing their diabetes with the dia management value of 1.72. These findings confirm that our tool is reliable and captures the key aspects of diabetes experienced in the rural population. Now, these are the results of analysis of variance, that is the ANOVA. Our ANOVA results show how different groups vary across the three diachromor component. For the age, younger adults generally reported better health, while the symptom increased with the age. Traditional practices were most common in the 21 to 30 age group and declined after the 50 age. Diabetes management habits, however, similar across all the age group. For the gender, only traditional health practices shows a difference. Men reported using traditional remedies more than the women. Health and management scores were similar across both the genders. Education had a clear impact. People with the higher education reported better health and fewer symptoms, but the education did not affect traditional practices or diabetes management behavior. Occupation also show impact. Government and private workers shows the best health scores and use traditional practices more than the other groups. Management behaviors differ too, with the other occupation group management diabetes the most effectively. And when we look into the BGL, people with the normal BGL had the best health scores, while those with the higher BGL reported the poor health. Traditional practices use was the highest in the high BGL group. Finally, when we compare, sorry. Okay. Now the diabetic status. Mm, When we comparing the diabetic and non-diabetic, non-diabetic reported better health. Non-diabetic reported better perceived health, while the traditional health practices and management behavior did not differ between two group. Overall, these results shows that the age, education, occupation, and diabetic status influence the health perception, while the traditional practices vary based on the age, gender, occupation, and BGL. And the third factor, diabetes management, remains similar across most of the group. Now, this is the discussion of our study. We basically create a 36 item survey that fit the culture of the rural Himachal. Their factors identify that is the dia health, trad health, and dia management. Explain strong psychometric structure and showing how rural communities mix the traditional and moderate care. Um we found that the traditional habits and factors like age, education, and occupation strongly affect how people manage their health. This tool can be used in the future for AI based personalized screening and better rural health planning. Our study has some limitations, small sample size, data from one region, no clinical test, and low KMO value. In the future, we plan to collect data from more places, including the medical tests, check long term results, and link Diacomod with AI and telemedicine tools. Now, these are some references, and then we thank all the rural participant in the our study, and thank also IIT Mandi for their facilities. If anyone have any query, then please let us know.
Thank you so much for your presentation. So, do you have any questions?
Yeah. So,
So, we cannot hear you.
it was a nice definition, and you can keep going on this definition.
Okay. So, we'll be moving on to the next presentation then. Next, we have Siddharth Joshi to present his paper titled PhilLitNet, an intelligent ICT framework for predicting financial inclusion through digital literacy and fintech adoption. Are you there, Siddharth?
Yes, ma'am. Am I audible?
Yeah, you're audible. You may please begin with the presentation.
Okay. Are you able to see my screen?
Yes, you may start.
A very good afternoon to all respected chair, designated panel members, and fellow researchers. I am Siddharth Joshi from ICFI Business School of ICFI University, Dehradun, India. And today I will be presenting a paper titled FinLiNet, a intelligent ICT framework for predicting financial inclusion through digital literacy and fintech adoption. This is a joint work with my co-authors from ICFI Business School as well as from ICFI Law School, Dehradun. The study proposes an integrated ICT driven predictive frameworks to understand and enhance financial inclusion in emerging economies. Here are the content starting from introduction to literature review, then research methodology. After that, their research and analysis, and concluded to the implications, conclusion, and at last references. With this, starting from the introduction, financial inclusion is widely recognized as a cornerstone for economic growth, social empowerment, and equitable development, particularly in emerging economies where a significant proportion of the population remains unbanked and underbanked. While access to financial services they had expanded due to digitalization, deep-rooted digital and social development behavioral barriers such as low trust, limited awareness, and inadequate digital capability continue to restrict meaningful participation. Fintech innovations like mobile banking, where digital wallets and mobile lending have import outreach, but their effective depends heavily on the user's cognitive readiness and digital competence. So here are the literature review which I have done. First, the rule of financial literacy. This brings us to digital financial literacy or DFL, which refers to the knowledge, skills, and confidence required to digital financial services secured and responsibly. Individual with low DFL, which is digital financial literacy, struggles to evaluate risk, navigate perform, and adapt with advanced services, thereby limiting the inclusive potential of fintech. At the same time, repeated fintech usage can enhance digital skills, suggesting a mutual reinforcing relationship between literacy and adoption, where the interaction is uneven across social demographic group, particularly affecting women, rural population, and economically dischallenged users. So this is the financial inclusion, and after that we have gone through with the fintech adoption and its role with financial inclusion, and then there's a digital financial literacy, which is the enabler of effective fintech use, and which is, at last which is an interaction between what is fintech between fintech adoption and financial digital literacy. So this is the ITC. We are doing an ITC based method for forecasting financial inclusion. Recent advances demonstrate the utility of ICT-based models and machine learning techniques in predicting financial inclusion patterns using demographic data, literacy indicators, and behavioral variables. These models help to identify unreserved groups, forecast usage trends, and evaluate policy inventions. ICT-driven predictive frameworks enable scalable, data-driven decision making for government and financial institutions. So here, after going through with the whole literature review, I have found a research gap, which is although extensive work exists on fintech adoption and digital literacy, but few studies integrate both within the unified predictive ICT framework. Existing research typically examines adoption without considering literacy or analyzes literacy without linking it to technology behavior, and rarely employs computation models to forecast inclusion outcome. The FinLitNet framework addresses these gaps by combining digital financial literacy, fintech adoption, and social behavioral factors to deliver a comprehensive, scalable approach to understanding and enhancing financial inclusion in emerging economies. So, here is the conceptual framework in which digital financial literacy, fintech adoption, and social demographic factors are linking towards the financial inclusion. So, as per the independent variable, digital financial literacy is a predictor, or which is also known as independent variable, through which we can access through knowledge, ability, and self-efficiency of participants in employing digital financial services. And we have also another independent variable, which is fintech adoption, which is assessed through usage frequency, range of services used, for example, mobile wallets, internet banking, and as per as their length of use. And the moderating variable, which is socio-demographic variable, which are age, gender, income, education, and geographic locations. And going through with that, the dependent variable, which is the final outcome, which is financial inclusion. So here is the research methodology to maintain clarity and consistency throughout the manuscript. All key terms are defined once and then used in objective forms. Digital financial literacy is referred as DFL, fintech adoption as FTA, and financial inclusion as FI. These abbreviations are used uniformly across the text to ensure reliability and alignment of academic writing standards. So, here's the research design. The research takes a quantitative explanatory research design to build and test FinLeadNet, a smart ICT model for financial inclusion prediction. The method is an interdisciplinary synthesis of behavior, finance, and technology, uniting data analytics with managerial expertise. Utilizing computational models, the model examines digital financial literacy, fintech uptake, and financial inclusion performance. So there are the three stages in which we have done the methodology. First, variable identification and operationalization, then data collection and processing, and after that, modeling and prediction. So this is the data collection. We have targeted populations, which is the adults between 18 to 16 age, both in urban and semi-urban areas emerging economies. Sample size which is 1200 respondents, ensuring diversity in terms of gender, age, and income level. Instrument, a structural questionnaire is assessed digital financial literacy, fintech adoption, and attitudes towards financial inclusion. So here are the result analysis for descriptive analysis statistics. The study involved 1200 survey respondents and analyzed transactional data from partner fintech platforms. The table 1 represents key descriptive statistics for the main variables, which is DFL, FTA, and FI, which is digital financial literacy, fintech adoption, and financial inclusion. After going to the test, the results indicate moderate level of digital financial literacy and fintech adoption, with the financial inclusion scores slightly higher than the adoption levels. QNS and values suggest acceptable normality for subsequent predictive modeling. After that, we have gone through with the correlation analysis, which is a sorry, Pearson correlation analysis highlights relationship between key predictors and financial inclusion. So after going with the test, the results are both digital financial literacy and fintech adoption exhibit moderate positive correlations with financial inclusion, supporting the hypothesized relationship in the FinLeadNet network. After we have done the predictive modeling results, which are the FinLeadNet framework was implemented using three machine learning algorithms, which are RF, SVM, and GB, which are random forest method, support vector support machine, gradient boosting. So after the result, we have find that gradient boosting achieved the highest predictive accuracy of 90% and ROC AUC 0.93, indicating strong discriminative power in classifying financial inclusion levels. So here are the implications from where we can implement the Finland advances financial inclusion
Sorry
research
to
by.
interrupt you, but you have 1 minute to conclude your presentation.
Okay. Research by offering integrated IC-based jointly analyzes financial literacy and fintech adoption. So the basic motto of implication the government can use in the NGOs as well as for the unurbanized population, where you can implement the financial inclusion as well. So there is a conclusion. Financial inclusion is a key driver of economic. To conclude, the study presents FinLeadNet, an intelligent ICT framework that predicts and enhances financial inclusion by jointly analyzing digital financial literacy, fintech adoption, and socio-demographic factors. Our findings confirm that digital literacy is the strongest driver of inclusion, and fintech adoption implies its impact when supported by educated user capability. FinLeadNet offered the scalability evidence-based pathway toward digitally inclusive financial ecosystem. Future research may extend this framework through longitudinal data, cross-country comparison, and additional behavioral or institutional moderators. These are my references. Thank you. Thank you for your time and attention, and I look forward to your questions.
Thank you so much for your presentation. Sir, do you have any questions?
No, madam, we can proceed. Am I audible?
Yeah, you're audible now.
Oh, we can proceed. No question.
Okay. Okay, thank you. Thank you so much for your presentation. Next we have
Thank you,
Dhruv.
ma'am.
Next we have Dhruv Gupta to present the paper title Mapping Communities in Scholarly Research, a Comparative Analysis. Are you there, Dhruv?
Yes, I'm audible.
Yeah, you're audible. You may please begin with the presentation.
So let me share my screen. Is my screen visible?
Yeah, it is.
Okay, sure. Okay, good afternoon, everyone. So I'm Dhruv Gupta from in IIT BHU Varanasi. So today I'm going to present my paper on titled Mapping Communities in Scholarly Research. Here by scholarly research, we actually mean the research articles or the presentation papers that we are actually currently discussing, on which I worked upon along under the guidance of my professor, Mr. Bhaskar Viswas. So let me first start with what is the idea behind the paper. So basically the idea is if we have a network of nodes or entities, let's say the nodes can represent anything, which here are representing the research articles. We want to make clear, distinctive, well-defined communities. So as to the community should have strong internal connections and very weak external connections. That is, the we can adhere some adjective or let's say a name to a perfectly formed community. That is, this community is representing something. So as you can see in the diagram itself, we start with figure 1a and we want to achieve something like that is being shown in the figure b. So the motivation behind this is that when any student or let's say any individual starts working on any research articles, so there is a data upstream or there is an ocean of data. So manually sorting or searching through that sea or vast sea of papers is nearly impossible or fundamentally very expensive operation. So with the digital repositories leading to a massive increase and the manual sorting not possible, and whereas traditional search-based algorithms work only on the keywords, not on the actual content or all the idea behind those papers. So our goal is to utilize some of the metrics or let's say some of the parameters of each research article to ideally form a network or a community within a network. So the methodology will cover two important aspects. First is the network formation, and the second one is the identification of communities. So in network formation, we started with a manually created data set of around 4197 research articles. This we can increase with time also. That is one of the future scope also. And we have the metadata, that is title, keywords, and publication year. With time, we also want to include the abstract of each of the article, because in definition terms, abstract should represent the entire article. So we perform some pre-processing and then we encoded or created the embeddings of those individual nodes that is representing the research articles. For encoding, we have used the BERT network. BERT stands for bidirectional encoder representation from transformers. I'll talk more about BERT in the next slide. So and then we formed a network using one of the most famous or globally accepted similarity metrics, that is the cosine similarity. So why BERT? So BERT, as you can see from the definition, has a bidirectional approach. Like there are many globally accepted other models also, like Word2Vec or Glove model, but they can't see in the future. Like BERT can go from left to right of a sentence and also simultaneously right to left. That is, it has the focus on both the past and present of a word to identify its context. While for other like bag of words or Word2Vec, let's say if we want a word bank, so bank of like our usual bank and a bank of river, for those models it is same, but BERT understands it like the word bank is used in which context. And we haven't like fine-tuned BERT much because we got pretty much good results using the pre-trained model of BERT only, which has a by default dimensionality of 768. Now going through the like once the network is formed, like using BERT, we made the embeddings and then we use the cosine similarity with a different threshold. The idea behind using cosine similarity is we just don't want to compare the content of each research article. We also want the idea. Like let's say for an article, if neural network is mentioned 10 times in one article and 2 times in another article, the traditional, let's say, European distance will Euclidean distance will discard this because the number of times neural network is used is different. But cosine similarity checks the direction in which that article is representing. That is, since neural network is being used, so it will consider them as similar. So based on different thresholds of cosine similarity, we have formed individual networks and then applied these community detection algorithms on this. So this is an exhaustive study of this community detection algorithms. I'll not go much into the deeper of I'll not go much deep into each of these algorithm. I'll cover some of them in the inferences, but let me know if anyone has any questions. So based on the thresholds that we use for varying uh, formation of networks, as we keep on increasing the threshold, the number of edges will keep on decreasing because this threshold represents how much bar that those two nodes have to pass to actually consider being similar. So greater threshold will give high signal to noise ratio, while less threshold will be a more dense graph, and each edge will not be that much meaningful. So from inferences and from our study also, we identified like an ideal sparse graph will have much more meaningful connections, and the algorithms will work much better on those graphs than the dense graphs. Sorry. So coming on the results part, so there are some metrics that we used. One of them is the number of communities, and the other one is the modularity score. So ideally, modularity represents how surprising communities, or let's say by surprising means what is the probability that this community is formed really, and not it is just not a random assignment. So the probability, if the probability is less, that means that the community is more statistically significant, and that is it is a surprise to us that that community is formed because with such granularity. So the higher the modularity score, the better the algorithm has performed in identifying clear, well-defined, crisp communities. So as you can see, Leiden performed the best because Leiden, what ideally Leiden does is that it forms a community and then it checks all of its neighbors. It checks if I include one of the neighbor into this community, will the modularity score increase or decrease? If it increases, and by how much percentage? So it double checks the percentage to avoid any miss. Let's say we have biology papers and we have AI papers, and in one paper biology, AI is applied in biology. So that doesn't mean AI and biology can be formed in a community just because of one node or one edge. So that is taken care by Leiden, and that is why it has achieved the highest modularity score. Next comes the number of communities detected. So communities detected is the highest in surprise algorithm. So what ideally surprise algorithm does is that it also checks the probability or the p-value of an actual community formed, and it discards the random assignment of those secure communities. So as soon as the we have less p-values, so that means that is more statistically significant, and that means surprise algorithm does better at identifying very granular communities, which if we go via the route of increasing modularity, it can actually merge two communities just to increase the modularity score. While surprise algorithm checks whether we can fine tune or fine gradient the communities into much smaller communities. That is why the number of communities will be much larger in the surprise algorithm. Now, if we talk on the basic trend, so as we keep on decreasing the threshold that is making the graph or the initial network more dense, the modularity and the number of communities will also decrease. While we observe, these are all experimental results, while you observe modularity shows not a sudden decrease, but a consistent decrease with varying threshold, but the number of communities decreased very sharply with a much larger gradient. So the idea behind is that as s- like if the communities are more if the network is more sparse, the connections are much more meaningful and they will offer much more knowledge for each of the edge, while a dense network is forming communities in a dense network will be like randomly assigning those communities. It is the same only, and it will not give much more information about those edges. So this is the general trend, that number of communities, as you can see from the graph, in 85% threshold, that is more dense graph, the red one, the number of communities and modularity on an average is less than the 90% threshold, that is the blue line. Now coming to inferences, Leiden has the highest modularity score that I have
Sorry
explained.
to interrupt you, but you have
Yeah.
1 minute to conclude your presentation.
Sure. In the surprise algorithm, the number of communities will be maximum. The NTM viability. So NTM is actually it checks the a recurring pattern inside each of the communities. So as long as the recurring pattern continues, the communities will keep on adding. So that is the fundamentally or mathematically speaking, that is one of the most optimizable approach for this community detection. Now label. So this density, quality, and density and cost that I have already explained, and optimal threshold we have choose as 90% based on the experimental results. So on concluding the slide, we have used BERT embeddings and cosine similarity to actually form the network, and then uh, differentiated or compared community detection algorithms on these. And the future work should include hybrid approaches, or let's say we can fine tune the BERT model, or we can include much more abstractions from the research article itself. That's it. Thank you so much. Please let me know if there are any questions.
Thank you so much for your presentation. Sir, do you have any questions?
So one suggestion is if you want to use this in real time, you can use the district one.
Okay, sure. I'll definitely consider that. Thank you so much.
Thank you so much. So we'll be moving on to the next presentation. Next, we have Vasil to present the paper titled Optimization of the Energy Subsystem in the Construction of Modern Field Medical Stations. Are you there, Vasil? Are you there? Vasil, are you there? Okay. So we'll be moving on to the next presentation. Next, we have Jaya Saxena to present the paper titled Vikas Vision-Based Identification and Knowledge Analysis for Solar Panel. Are you there?
Yes, ma'am. Good evening. I'm there.
Yeah,
Am I
you
audible?
Yeah, you are. You may please begin with
Yeah.
your presentation.
Just a second. Yes, please. I'm sharing the screen, madam. One second.
Yeah.
Is my screen visible? Is it visible?
Yeah, I'm just seeing. Yeah, it is visible.
Am I audible?
Yeah, you are audible and you the
Vikas, is
screen.
it visible?
Yeah, it is visible.
Yes. Thank you very much.
Yeah, you may please start.
Yes. Respected chairperson of the session, my fellow presenters, and the dignitaries present on in this online mode. Namaste and good afternoon, everybody. I'm Dr. Jaya Saxena. I'm working at National Remote Sensing Center, ISRO, Hyderabad, a scientist app. And this is one of the work which is done under my guidance with the help of a couple of graduate students, project students. I think they are also there on the in the online mode. They have also joined. Tejas, Shubh, and Aditya. In my guidance, we have done this work. We have named this work as Vikas, that is vision based identification and knowledge analysis for solar plants. In this work, we have tried to use the cutting edge technologies, that is artificial intelligence, large language models, deep learning, basically deep learning, amalgamating it with the geospatial technology and solving the crucial problem of present era, that is power. So we have tried to use solar power, try to harness the solar power. That is one of the SDP's sustainable development goals also. So we have tried to use solar power using spatial data, that is geospatial technology, and deep learning model to find out where are the solar plants and how we can identify them and then make use of them for the power generation. The crust of this problem statement is under different complex environments, that different topographies, maybe they are hilly terrains or water bodies or strategic locations like China border, Tibet border. The main crust of the problem is how to identify different type of solar panels. They are of different shapes and sizes, different colors. They are sometimes having, we are having sometimes large solar plants. Madam, how much time I have?
Just 10 minutes, like 2 minutes are already gone, so 8 minutes.
Okay. So I'll go fast with the introduction. The we have different type of solar plants. We have in Gujarat, we have large Badla, we have large solar Kutch area Badla, we have large solar plants which are easily identifiable. We have solar plants which are over the water bodies, like laid over the water bodies, like Ramagundam in Telangana. We have floating solar panels over. They are not fixed over the water bodies, but they are floating along with the water in the canals. We have different type of plants in strategic locations, as said that Tibet, etc. So how to identify those solar plants, solar panels with the spatial data, because it is difficult to go personally, physically go to those plants, solar, those terrains, topography, and find out those things. So sometimes the situation does not allow us, like I already told, border areas, this doesn't allow us to go and find out those things. Also, sometimes we want to, I being in working in RSC ISRO, we want to find out, like, if our neighboring countries, they are generating power, what is the source of power generation. They don't lay out plans which are easily identifiable even with the spatial data, with the satellite data. So, and we need very high resolution satellite data to find out those solar plants. So we have used a deep learning model to find out where are those plants, different type of solar plants. And then anyway, once we find out the plants, it is easy to find out how many solar cells are there, and then multiply with one of the power generation, and we can find out how much power is generated for that particular terrain, for that particular area, and helps us to achieve sustainable development goal out of those 17 goals. So this is our introduction. This is the problem statement we have. Literature, lot of literature review we did, because this is an emerging technology, emerging problem statement, and we don't have high resolution data available with us. We don't have the data available even with the Nexar, with the foreign satellites like Maxar, etc. Also, we don't have data of these solar plants. Rooftops are very easy. Urban rooftops or solar plants are very easy, but I told you, over the water bodies, different type of solar plants, difficult to identify. So we have used a deep learning model, ResNet 18. Finally, we pointed out to, we have started with convolutional neural networks and different type of CNN, RNN, and all that. Finally, we pointed out to ResNet 18, and we have used ResNet 18 for our our work. We have used open source satellite data like Landsat and Sentinel-2, Maxar, and then we have augmented the data, because those many data sets we could not get. We have augmented it with different angles. We have used Google tile map technology to create more data sets out of what we could achieve with using this open source or with Maxar, etc. Because whatever data set we are getting from airborne remote sensing differs from what we get from satellite remote sensing. So we have to augment to get more data for training and for validation, etc. So data collection is one of the important tasks which has taken most of our time. We have whatever data we could get, we have augmented it to create more, and then we have used Google tile map technology for creating for digging out the best possible data set out of what we get as a particular satellite pixel. Then we have used different type of Python libraries and Python source Python code we have written. We have used different type of libraries to find out whether it is a solar panel or not. It's not a solar panel. Just for example, this is one of the image we have gathered using Sentinel-2A, and with this image, like what we are seeing in the left hand side, this is a image from satellite. It is Sentinel-2, so 10-meter resolution is the resolution of this multispectral satellite data. Now, with this image, it is difficult to train the deep learning model, so we have used Google Tiles API, and then we have digged out the solar panels out of the satellite image. So this is what we are seeing at the right. Similarly, we have taken image from different type of from different terrains, different locations, topography, different type of solar plants. Like as I told you, Badla, that is in Kutch area in Gujarat. That's a very large solar plant over on a path they have made it. So that's easy to identify. But second is rooftop solar panels. That is also difficult. Over a stadium, it is easy, but over urban areas, it is difficult, because we get it interferes with, and we get wrong negative answers with the tin shades or with the window panels, tinted window panels. So difficult to identify. Sometimes urban rooftops also, if they are very close to each other. The third one is solar canal. It is in Vadodara. It is we are seeing the solar panels over the canal. So this is one of the type. Then fourth for the scattered solar panels, and high altitude solar panels in Leh Ladakh. This is the most challenging task for us in serial number 5, that is high altitude solar panels, because this is one of the strategic location also. If China is generating power in that area, what is the source of their power generation? And they mask it, they hide it, they camouflage it, so it's very difficult to find out. 6 is a floating solar panel. It's in Ramagundam, Telangana region. It flows with the water. So these are different type of solar panels, which what we have considered. We have and this is just a presentation of what are the images we have done in a nutshell. And different type of plants: 15% of solar floating, then scattered 15%, hilly terrain 10%, plain land 25%, solar images, and the false the false images, that is the negative outcome, non-solar images. So with this, we have trained our deep learning model ResNet 18 with the true positives and false positives. Then we have done data processing. These are all techniques what we applied: resizing, normalization, because a lot of error is also present. So and it is tilted in at a different angle. So normalization, mean subtraction, data augmentation. As I already told you, with Google Tile API and with different type of augmentation, we have created more data with what we have already there. So resizing, because satellite is more in size, 1 meter by 1 meter. We have taken 224 by 224 pixels. That 1 meter by 1 meter also depends upon type of the satellite what we are using. So we have done data augmentation, different type of techniques what we have done for this. I'm presented in this slide. And errors, a lot of errors we could get in during the process because of the blurriness, because of rotation of the different augmentation at different angles, because of color jittering, because of satellite movement. This very few data we could get from which are truly rare from Maxar or from Sentinel 2A, but other things we have created on our own. Then this is our model which we have trained, ResNet 18. This is the basic model. We have not done any modification in the model, but we have definitely used different type of models, and out of that we could get the ResNet 18 works best. We have also generated a web application for that GUI so that it can be usable. The community can use it. So we have used this is a screen snapshot of the first screen of our graphical user interface, in which we have used Google Map. We can go Google Map, or also our Bhuvan map we can use, because being in ISRO, it is good to use Bhuvan map. So we have a plan to link it with our Bhuvan. We can go to different locations like that, and any location you point out and you select, it will tell us whether a solar panel is present or not present at that location. Once it is present, then we anyway calculate it. We can highlight that image and we can calculate how many, and then multiply it with the energy generated with one pair. And there are different options available in this GUI. That is, we can also select, either we can point out, we can select a location, or we can give latitude, longitude of that location. We can also use we have a CSV file. During our work, we have generated a CSV file where we could find out some location. So we can directly upload that CSV file, bulk upload, as we are seeing, as it is shown here. Upload CSV, and it will tell us whether this is a so in a bulk, it will show whether it's a solar panel or not a solar panel. So with different features, what are there is map interface, coordinate management, features of the GUI, coordinate management, single coordinate prediction, area scan. We can also scan a particular area, 2 meter by 2 meter, and then it will tell us in that area whether solar cell panel is present or not present. If we are not able to identify a pinpoint, we can also scan an area, and the system will tell us whether it is there or not. So different type of features are there, and this is the screen snapshot of our result, which we got from scan. So we have scan a particular area. Out of that, it has shown us whether it's a solar panel. See, in the first thing, it shows not a solar panel. Here it is a solar panel. So like that, we have done. Coming to the result and conclusion, we have achieved 98.61 training accuracy and 97.7 was a validation accuracy. That's a very good accuracy, more than 97% for both training and validation. And ResNet 18 model we have used. So this is in deployment stage right now. And also, if our future work is, if we can train the model with more data, we can even achieve 99% accuracy. But definitely with this work, we are able to achieve one of the SDGs, that is Sustainable Development Goal. With this, I conclude my presentation. I think I'm on time. Thank you very much for your patience listening, and I'll be happy to answer the questions if you have any.
Thank you so much for your presentation, ma'am. Sir, do you have any questions?
So, ma'am, this application is basically for government, I think, to decide whether means the area is dense with solar or not. Is it so?
Yeah, yes, sir. Please continue, sir.
So, is it like that? This application is helpful for government to check which area is dense with solar and where to focus.
Yes, sir. Basically, it will be more useful for government organizations to find out where are the solar panels present there. But it is also useful for the NGOs or for the governments for the private sector which is working in renewable energy sources. So our basic aim was to tap more on the renewable energy sources, different type of sources which are present. But if we compare, yes, sir, it is more for the strategic uses or for the government sector.
Okay, ma'am.
Thank you so much for your presentation. Uh, do we have Vasil to present his paper?
Yeah, thank you very much, and I'm very much thankful to the management, to the forum for giving an opportunity to present our work. Thank you very much.
Thank you. Do we have Vasil to present his paper? Okay, I guess not. So, I sincerely want to thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ICTCS 2025. Before ending this session, I would like to take a moment to thank our session chair, Professor Ronakawar Patel, for chairing this session. So this is a token of appreciation on the whole team of ICTCS and Global Knowledge Research Foundations and partners. Would you like to share a quick closing remark with us?
Yeah, thank you very much for this opportunity. And I sincerely thank all the authors and presenters for their valuable contribution to this session and the quality research and diversity of ideas they presented and reflect the strong academic focus of this ICTS 2025. And my thanks to the conference chairs and organizing team for this smooth conduct of this session. And thank you very much all and keep researching.
Thank you so much for your valuable presence, sir. I would request everyone to kindly turn on their cameras for a quick snapshot before we end this session. Thank you so much, everyone. Thank you for your valuable presence.